Welcome to this fifth and last webinar in the webinar series of EESSI. So this one will focus on building a central software stack on top of EESSI, so using the EESSI software stack as a base and build your own site installations on top of that. My name is Dröge. I'm an HPC consultant at the University of Groningen, and I will present today together with Caspar van Leeuwen, who's an HPC consultant at SURF in the Netherlands. And my colleague Pedro is also here today. He also helped out quite a bit with preparing the slides. Yes, so some helpful knowledge for today. It's not strictly required that you know all the details of all these components, but most of it has been covered in previous webinars this year. So in that sense, this webinar itself also builds on top of all the previous ones, because we're gonna heavily rely on what EESSI provides, what EESSI Extend can do. So EESSI Extend has also been covered in one of the previous webinars. We're going to reuse that, but then in a slightly different way. We will, of course, use EESSI builds to do the site installations, the software installations, and it uses CVMFS a lot because EESSI itself uses CVMFS, and we're also going to explain how you can actually add your own installations to your own CVMFS repository. So if you're already familiar with these topics, that will really help in setting things up if you're gonna do this anytime soon. Also, it's helpful if you already know how to make EESSI available and how to use EESSI build. Bonus things are if you're already familiar with LMOD. I think quite a lot of people managing HPC sites use LMOD for making the modules available, but that's what we use with EESSI and what we're also going to use for the site installations. Containers is not really necessary. We will talk about that a little bit, but it's not really required that you know a lot about it. So the agenda for today's session, I will do a quick introduction on some of these EESSI topics and components that are useful to know upfront. Then we'll continue with the first approach, where we basically use EESSI Extend to do site installations on a shared file system to which you can directly write, like an NFS share or Lustre or GPFS. That's a really easy scenario. You can set it up in like a few minutes if you want to and start building your site installations. But then to add more automation and also to basically reuse all the workflows and the build scripts that we use for the EESSI builds themselves, Caspar is going to show how we've recently put quite a lot of effort in changing all those scripts in such a way that you can basically just run the exact same thing that the EESSI build jobs also use, so the EESSI bot, the EESSI scripts, etc. And that makes it really easy to install stuff in the exact same way as we do ourselves for EESSI. So that will be a long demo of how that works, but then in the end, you hopefully will be prepared to set it up yourself for your site. And then in the last part, we have some special cases, like how to basically rebuild some software installation if you find out that there's an issue, how to ship licensed software to your users, how to actually configure your nodes to pick up the EESSI installations, the site installations, but also EESSI itself, how to make that stack available to your users. And then at the end, we will have some future work and discussions and, of course, time for questions. So I'm quickly going to go through some of these topics. This has been covered in almost any of the previous webinars. So I hope you're familiar with EESSI by now. But again, EESSI provides a shared stack with optimized software installations for quite a lot of different CPU targets, 15 right now. For the site installations, it's not necessary, of course, that you build for all those 15. That's the whole point, that you can do this yourself as a site, and you only build for the ones that you're interested in. But still in the same way as EESSI does it, so it will still be useful or usable on different systems with different CPU types. This picture you've probably also seen quite a lot of times by now. Just to stress again that EESSI has different layers providing different functionality. For this particular webinar, the file system layer is sort of important because we will, especially in the second approach that Caspar is going to show, you will configure CVMFS yourself with a stratum 0, stratum 1, etc. So you will basically redo what EESSI has done, but then for your internal builds. And the installations themselves, of course, that's the software layer. So you're basically going to extend that software layer beyond what EESSI provides itself. The compatibility layer, we will not really touch that today, since we will basically just reuse the existing compatibility layer that EESSI already provides. So you can basically just reuse that and do your own builds on top of that compatibility layer. Also wanted to show this diagram again. We've also shown that one in several presentations and webinars. But this is in particular important for the workflow that Caspar is going to show in the second approach, because we will basically mimic what EESSI is doing, but then in a slightly easier way. So how do we currently add software to EESSI? Basically, anyone can open a pull request, so that makes them a contributor. You can just open a pull request to the EESSI software layer, GitHub repository, and add some EESSI config to the EESSI stack. So that can be, let's say, a new Python version. You basically have to add one line to the EESSI stack file saying, I want to add this version of Python to EESSI. Then someone from the EESSI team will start reviewing that PR. If things look okay, they can start build jobs with the EESSI build bot. In total, we currently have to trigger 15 of those. So typically we start with just one or a few, and then whenever that succeeds, we will launch the other ones. But before we can actually proceed, all 15 have to succeed for all the 15 different targets. That can sometimes take a while if there are issues for particular systems, but well, if you're lucky, they all succeed. Also, the tests pass. And then we can start deploying that. So that basically means shipping all the tarbles, all those 15 tarbles, each with a single installation, or with the installation for a single CPU target. We ship that to a S3 bucket, where we basically collect all these tarbles. And then in order to actually ingest them to the repository, there's something running on our Stratum 0 server. That's basically just a cron job that's pulling that S3 bucket for new tarbles. And whenever it finds them, it figures out, okay, this tarball belongs to that software layer PR, and it collects all of those, so all the tarbles of that single software layer PR. And then it opens another PR in a private repository where only a few of the EESSI maintainers have access to. And they do a sort of final review. So they check, are all the tarbles here? Is the contents as expected? Are there no weird files in that tarball? If that all looks fine, and all the 15 tarbles also look similar in a way as same number of files, etc., then we merge that PR, which is basically the final approval, which says, okay, go ahead, ingest these tarbles to the repository. Whenever the cron job then detects that the staging PR was merged, it will go ahead and actually merge the tarbles into the repository. And then a few minutes later, the installations will end up on the Stratum ones and then on the client. So then you can actually use the software. Well, this is just a few numbers of the amount of software that we already have available in EESSI. So there's actually quite a lot. So a lot of modules. I'm not going to read out all the numbers, but we have different versions with different numbers of software installations. And well, this keeps growing and growing, as you can see. So in that sense, EESSI already provides a lot of installations. But of course, it doesn't have everything. So that's also the sort of main motivation for this session. Because you as a site probably want to add stuff on top of EESSI. That can be for different reasons, either because you have some kind of licensed software or commercial software that cannot be shipped in a public software stack like EESSI. Some software just doesn't allow that. And for those, you will have to install them locally on your system. But it would still be nice if you can install them on top of EESSI in the same environment, so that they sort of get merged into the same stack for end users of your system. Another one, it's just for simple software, even if it's open source. If it's not available in EESSI yet, you might not want to wait until it becomes available in EESSI. Sometimes that can be done very quickly. If there are no build issues, we can quickly ingest new stuff to EESSI. If there are build issues, for instance, for ARM systems, and you don't want to wait until we figure it out, you can, of course, go ahead and start installing that into your own stack if it's urgent, which is another motivation for doing this locally. And finally, you might have software which is really or needs specific kind of tuning or configuration for your system. Perhaps it's still possible to ship it in EESSI, but if you want to make changes to that installation, you can build it on top of EESSI in the way you want it to be. All right, so how can we do that? So for the first approach, I'm going to assume that you just want to get started quickly. You don't want to set up CVMFS infrastructure, maybe because you already ship a local stack on a shared file system. Then you can basically just reuse that for easy and start building a sort of new stack, which is separate from the existing one that you already have, but then you build this new one on top of easy. The pros of this approach are that it's very easy to do it this way by using that easy extend module, as I will show in a couple of minutes. It will do all the configuration for you, so there's not that much that you need to do. You can just specify the prefix and get going. You just start installing software in sort of the same way as you've done before, assuming you've used EasyBuild for your local stack before as well. Another bonus that you get from Easy Extend is that it by default will install software installations in an architecture-specific prefix. So that means that if you install, let's say, the Python version with Easy Extend, it ends up in a subdirectory specific to that CPU target. So like x86-64/AMD/Gen5, and then /software or modules, which is something you don't get automatically when just using plain EasyBuild, for instance. Then you have to be careful if you use the same prefix that not different kind of CPU type installations end up in the same prefix, because then you might get illegal instructions. So you have to do that yourself. By using Easy and Easy Extend, you basically get that for free, because Easy Extend will do the CPU detection for you, and it will make sure that that CPU specific prefix gets appended to your installation path. Also, for your extra users, you can easily then make those available again by looking into the specific CPU prefix for the system they're running on. Then some disadvantages of this approach. It's still sort of a lot of manual procedures. So you can just load Easy Extend and start building this, but you have to make your own automation around it. Maybe you already have something like that for the current stack that you have. Then you might be able to partly reuse that for building on top of Easy. But all the workflows that we use for Easy, you cannot easily use them because we sort of assume that it's CVMFS based. There are lots of assumptions in the workflows that we do for this. But still, just getting started, that's quite quick, I would say. Another one is that if you do this on a shared file system, maybe you already do it that way, but shared file systems typically are not that suitable for software installations. So in that sense, it's quick to get started that way, but if you're going to provide a large stack on your shared file system, it might become slow, while CVMFS was specifically created for shipping software installations. So typically you will see that it's very good in handling software installations, and it will be very fast. So just to give an overview of how this would look like. So to build on top of Easy, you of course need Easy to be available on your site already. For that, you need some small infrastructure to be in place. For instance, the sort of minimal setup that you would need that's listed here. So for an HPC cluster, we typically recommend that you have at least 2 squid proxies, which will do local caching. So basically any modules that users pull in will then end up in the squid cache. And then if they need it again, they're typically still in the cache. So you don't need to contact the Stratum 1 servers of Easy, the public Stratum 1 servers all the time, because that might overload them. So to prevent that from happening, we would at least want HPC clusters to set up a bunch of squid proxies. And the recommendation here is to have at least 2 for 2 reasons, both for load balancing. So then some of your nodes might be using the first one, the other ones can use the second one, and also for redundancy. So if you need to do maintenance, for instance, you can reboot one first, then the other one is still there, and CVMFS will automatically fill over to the second one. And then once the first is back, you can also reboot the second one. Of course, more cache is better, so larger disk is better, and more proxies is better as well. So the more clients you have, the more proxies you might want to add in the future, depending a bit on the load and how heavily you're going to use Easy. You can set up your own Stratum 1, for instance, but that's something that we will cover later on. For now, we're just going to assume that you're going to do the builds on the shared file system. So that's also connected to your HPC cluster. And then with this setup, you can already get started. So that's what I'm going to do in this first approach and in the demo in a few minutes. How would that work in practice? Well, basically, you just use EESSI. That was already covered in one of the previous webinars, but then more for user-specific installations. EESSI have different kind of modes in which you can use it by setting some environment variables. For this one, we're going to say export site EESSI site install equals 1. That means that we're going to do site installations. The difference between user project site installations, I'm not sure in how much detail that was discussed. The differences are not that much. The main difference are, for instance, on the permissions that the final installations get. So for site installation, the permissions are basically wide open so that every user can access those installations because they're site installations. And there's one other important thing that you can configure. This is a new feature, so that's option 2 here listed on the slide. In the past, by default, all site installations would go into this special host injections variant symlink. So that's a symlink that you as a site can control and configure in your CVMFS configuration. So then you can point that host injections directory, which you will see here in that path CVMFS software.easy.io/host injections. You can point that to any directory that you want. You can point it to a shared file system or to a local disk, whatever you want. And previously, that's also where site installations would end up, which we thought would be useful. But now that we started adding more and more stuff into easy host injections, for instance, GPU drivers and CUDA installations, maybe you want to override MPI libraries that would also go into host injections. We figured that maybe for some files you want to have these on a local disk, for instance, GPU drivers, it probably makes sense to have these on the local disk and then point host injections to a local disk. While for site installations, you probably want to have those on a shared file system. Now, there were ways how you could achieve this by setting up your own symlink structure inside of this, but that gets quite tricky and advanced. So we basically added a new way to set another environment variable, EESSI site software prefix, which just overrides the location for software installations only. So then still all the other stuff like GPU drivers would go into that host injection symlink. But with this variable, you can control where the actual site software installations go. So you can point that to any directory you want to. So for instance, your shared file system. And you have to do that before loading the EESSI module. So the order on this slide is important. So set EESSI site install to 1, set EESSI site software prefix to your preferred path, and then load the EESSI module. And after that, load EESSI. Then EESSI should be fully configured to do your site installation in the path that you want to. One important warning or remark here. EESSI itself does not do any kind of automation, let's say, for doing the builds for all the supported CPU targets. So by doing this, you basically have to redo the steps of the previous slide on every kind of build node that you want to support in your cluster. So if you have 4 different CPU types in your cluster, you still have to do this like 4 times on each of the different types of machines. That's sort of a pro and a con. You get the optimization for free from EasyBuild and EESSI, but still you have to repeat that step many times. So just to show you how that works, I will switch to our university cluster, Habrok, where we already have CVMFS also for our own stack, but I'm going to ignore that for now. EESSI itself is available. I'm going to set up a new empty directory for site installations, just for the sake of this demo. I'm going to use a standard user account, like a staff account, for doing the site installations. So it can be any account that you want to. And I'm going to use EESSI to build on this machine. And this machine is a machine running on Alma Linux 9, and it's a AMD Zen 3. So let me switch to the right screen here. So this is a sort of test login node that I have here, called after a bird, a merel in Dutch. And I'm going to start with my Bob account, which is an admin account, just because I need to make a dummy directory for which I will which I will be using for the software installation. So I'm going to make that under /software. And I'm going to actually use a, as we call it here, a functional account. It's sort of a shared account, but without any special privileges, which is the one in the second tab of my terminal here. I'm just going to give that permission to do the software installations in that directory. That's basically everything I'm going to do with root privileges. So now I'm going to switch to the second tab and actually use this standard user account for the actual site installations. So now I'm just going to do the commands that I listed on the previous slide. So I'm going to enable site installations. I'm going to set my software prefix to /software. I'm going to load EESSI, which is already available on our system as a module. We basically just added the EESSI module directory to our module path, or lmod module path, so we can load the EESSI module. And then you will see some message here with a weird looking version. That's not an EESSI version. That's basically our own software stack on our cluster. So that has nothing to do with EESSI, but we sort of prevent that users can load both at the same time. So it switched our regular software stack with the EESSI software stack here. And then I'm going to load the EESSI extend module. And as you will see, it already gives a sort of warning saying, make sure that you have write permission to this path. So it correctly picked up the software prefix that I want to use here, so /software. And that's basically it. So now I can start doing installations with EESSI build. So EESSI extend will make sure that EESSI build itself is also loaded, which I can check by just checking where EESSI build is now coming from. You will see that EESSI build is installed in the EESSI software CVMFS repository in the Zen3 prefix. If you want, you can even print the full EESSI build configuration or the short version of the configuration. So you can check all the things that you want to check here. Let's make it a bit wider. Maybe an important one to check is the installation path. So that's indeed correctly set to my defined software prefix. And there's a lot of other configuration that EESSI extend will do for you. That's basically just the same configuration that we use for the EESSI production software builds. And now I can install whatever I want. So I'm just going to pick a few easy and quick installations. So for instance, Caspar, that will be done in like a few seconds, I hope. So you see that it starts installing it, and it indeed starts installing it to /software. And then it's done. I can do another quick one. I think I use this tool, which is also quick to install. And once that's there, I can actually start using it. It takes a little bit longer. Building. Meanwhile, I'll go forward in the slides, which just shows the same thing. So if you want to read this back later, you can find everything in the slides. Yes, now it's done. Now I'm just going to run module avail, and now we should see the installations pop up. So you see some different kind of module path listings here, but the one with our site installations should always take precedence. So it's at the top. So here you will see here are the site installations, the ones that I've just done, and then all the regular EESSI installations are there as well. So I could load one of the module that I've just installed. I'll say, just to show it again, you will see that Caspar was installed in my software prefix in the same kind of path as EESSI itself uses. And then I can run something. And that works. So this is a really nice and quick way to get started and start building software in a actual software prefix on a shared file system. One more detail, because before I hand it over to Caspar, if you want to do it in an even more similar way as EESSI does it, you could run all of this also in a container. So I now just ran it natively on a host, on a login node of our cluster. You could use, for instance, the same build container that EESSI uses by using this easy container.sh script that we ship in our software layer scripts GitHub repository. We typically use containers for all our builds for several reasons. One of them is that we have a sort of controlled environment. We're always sure that we get the exact same sort of OS packages when we do software builds. It also prevents you from accidentally picking up system libraries. There are still a few installed in the container, but as few as possible to prevent that it starts finding libraries in the container itself, which you don't want to pick up. You basically only want to pick up stuff from the compatibility layer. So that's why we use this container. But other than that, you can use the exact same procedure in the container, as you see here. So the exact same commands also then work in the container. The only detail is that you have to make sure that your directory is, of course, available in the container, which you can use this -b flag, which will do a bind mount of that prefix into the EESSI container. So now I'm going to hand it over to Caspar, who will focus on using the same workflow that EESSI uses.
Yeah, thank you.
I'll stop sharing.
Let me share the screen. There we go. All right, so the second approach is that we'll try to leverage as much of EESSI as we can. So basically, we'll try to use all of the build scripts that EESSI itself uses, and the only difference will be that we'll install in our own site-specific CVMVS repository rather than software.easy.io. Again, a pros and cons list. The pros of this is that it's highly automated. We leverage the same automation that we've set up for EESSI, and of course in EESSI we built for something like 15 CPU targets, and then for GPU installation that goes times, I don't know how many GPU targets we have, something like 6 right now. So we really needed that automation to build for all of those targets, and you basically get that for free as well if you take this approach. So it's scalable to many architectures and many installations as well. I mean, in EESSI itself, we have hundreds of installations. So no matter how many site installs you want to do, this will definitely scale to that size. What you will actually need to do is set up a small GitHub repository that lists the software that you want to install. The advantage of that is that you have a clear list of what's available on your system, right? So you can even point externals to it and say like, look, even if you don't have access to the system yet, this is the most up-to-date list because this is the one we're actually building from. It also means you can share maintenance on the automation part with the EESSI community. Of course, you can take the setup that Bob just introduced and write your own automation around it, or maybe you already have some automation. And that will definitely work, but then you have to maintain it yourself, right? So that's, yeah, I mean, here you get something for free if you share it with the community. And finally, the end user look and feel is very similar to EESSI because, again, it's just installed in a CVMVS repository. It's just a different info repository, and the rest of the software prefix looks completely identical. Of course, there's cons as well. It's definitely requiring more setup time. It requires more extensive knowledge, as you'll see, like as we go through the demo. You see that you need to know something about CVMVS. You need to know something about how the EESSI build bot works, and for that you need to know a little bit about GitHub apps. For now, you need an object store. We might add some functionality later down the line where you don't need this anymore, but for now that's still required. You also need more hardware resources because you need to set up your own CVMVS infrastructure, your bot infrastructure, and that means that on the installation side, you have also more components to maintain, right? So this bot installation, yeah, every now and again, you probably want to go in there and update the version of the bot installation that you're running. All right. So the goal is to build everything using the dependencies from EESSI, just as Bob did, but then in a CVMVS repository of our own with the EESSI build bot and using the same build scripts that EESSI uses. And those are basically hosted in a repository, EESSI/software layer scripts. What we need for that is we need our own site-specific CVMVS infrastructure. So that means a stratum 0, a stratum 1, proxies, and clients. Of course, the clients will be on your batch machines that you actually want to provide the software on. And you will probably already have that if you provide EESSI there, but you'll need to add a configuration for your site-specific CVMVS infrastructure. You also need one or more instances of the EESSI build bot. I mean, if you have a single cluster, you can do with one instance, and it just runs somewhere on typically a login node, and it can farm out the build jobs to your cluster. But if you want this to be available on several clusters that you manage, then you probably need one build bot per cluster, unless they share the same microarchitectures, right? So then you could do with only one. So this build bot, the goal is that you want to build natively, right? So it needs to have access to all of the targets that you will eventually want to support. Regarding the object store, you need a bucket in some AWS S3 compatible object store. So this might be your own, it might also be an actual AWS object store, doesn't matter. As I mentioned, a small GitHub repository to list the EasyStack files. That is very simple to set up, as I'll show later on. And it just lists in EasyStack files the software that we will want to build on top of Easy. And then finally, and optionally, you can automate the procedure to actually ingest the tarballs into the CVMFS Stratum 0 machine. You could also do that manually, like it depends a bit on how far you want to take this. So what is the recommended CVMFS setup then? On the top right, we basically had what Bob already showed, right? That's the easy infrastructure that we offer publicly. Then you probably already have squid forward proxies on your machine to proxy the easy software stack. What you want to add to that is your internal Stratum 0 for your site CVMFS repository. And of course, that also needs Stratum 1 servers. So in this picture, we'll add 2. That will be the recommendation. And then you can configure the same proxies to actually also connect to those Stratum 1 servers. So the proxies you can reuse in this setup. We want 2 Stratum 1s for redundancy, basically. Like if you only have a single Stratum 1 and it would die, then yeah, your clients can still get whatever is in the proxies, but if they try to access a new file, it will just be unavailable. Because normally they cannot access the Stratum 0 directly. They have to go via Stratum 1. You could also have one of the Stratum 1s mirror the easy repository. That is something that we have, I believe we have this documented as well. That gives you some resilience against network outages, right? Because then you basically have the full easy software stack locally. So even if the connection to the internet would drop from your HPC system, as long as your clients can still reach your own internal Stratum 1 servers, they can still serve both the easy repository and your local one. And especially if you're building on top locally, I think this is even more important because you don't want your local software stack to break if for some reason the public easy infrastructure would be unavailable. And then at the bottom right, there's a small snippet for the client configuration that you can use just by setting the CVMFS server URL and then first adding your local site Stratum 1. And then just using the $CVMFS server URL, it basically appends all of the public infrastructure at the end. And then if you disable the CVMFS use geo API option, it will just go through the list in order. So it will first try to approach your local Stratum 1. If that is unavailable, then it will go to the upstream public infrastructure. It's important to disable this geo API because otherwise it will try to do geolocation based on the IP addresses, and probably your internal Stratum 1 is the closest in terms of networking, right? But then the question is, does the geo API really return that result? It's better to disable it because you already know that this thing is going to be the closest. Again, we have 2 proxies because you still want this redundancy and load balancing. You could have more if you have a very big system, of course. And then the first step is actually to set up this Stratum 0. So for this demo, I've set up a repository called software.caspar.nl. Mind you, this is not actually a URL, right? It's just a name of a CVMFS repository. So yeah, there's no web address or anything linked to this. It is quite common that, in my case, I just tell my clients to directly connect to some IP address. Of course, you can set up a DNS, and then it's quite common to reuse the same name. Otherwise, you're just going to confuse people. So what do you need to install on that Stratum 0 machine? You need to install CVMFS and CVMFS server. Then you create the repository. So you do a sudo CVMFS server makefs, and then -o tells CVMFS server which owner you want for the repository. That's basically all of the files are owned by this user on the Stratum 0. Here we're making the root user the owner. And we'll actually get back to why we do this. and then I pass it the name of the repository that I want to create. Then we need to make sure that the web service is running, so either Apache 2 or HTTPD. Just check that that service is running. And basically, I'm not going to go into detail here because there's so many steps that if we cover all of them in detail, it will actually take way longer than we have in this webinar. But I will link the documentation that we already have. So there is a very nice tutorial that we did before together with the Chief Invest team on setting up a Stratum Zero. And if you basically follow those steps, yeah, you should easily get there. So, okay, let's show what that looks like. So this is the machine on which I set it up. So we can ask the Chief Invest server command to list the repositories, and I actually had a couple here, so I will specifically grab for this one. And here you can see it indeed found software.caspar.nl as a repository, and this machine is acting as a Stratum Zero for that repository. Another thing we can check, the mount command. Again, I will only grab for this one. What you see is that it gives you two mounts, software.caspar.nl, which is basically a read-only fuse file system. And then there's an overlay. Now, I don't know how familiar you are with overlay file systems, but the idea of an overlay is that on a certain mount point, you can overlay two different other directories. So there's a lower directory and an upper directory, where the upper directory basically takes precedence. So if a file is present in both, on the overlay directory, you will see the version from the upper directory. And this allows CFinvest to show on this /cfinvest/software.caspar.nl basically an overlay of a lower dir, which is read-only. That's sort of the current state of the repository. And then the upper dir ends in /scratch/current. That folder basically holds any files that you're adding to the repository in a certain transaction. So that's basically your scratch base. And then once you finalize the transaction, all of that gets copied over to the read-only directory and the transaction is finalized. Right. What else did I want to show? So one of the things that might be useful to know is where it stores all of this stuff. Bob already mentioned that the SRV directory, like the location of the SRV directory, I think that determines where it is stored, right? So you have SRV, CFinvest, and then the name of the repository. There's a data folder in there that basically contains all of the data in your repository. If you want to store this somewhere else, like if you don't want it in SRV, but you want it on some other file system, you can actually make a symlink out of the CFinvest directory or even out of the specific repository if you want to, if you want different repositories to be on different storage backends. And then if we look at the repository itself, so this is basically that overlay file system. That's basically showing the current state of the repository, plus any unpublished, or after all the transactions are published, right? So this is basically what it looks like right now. There's a versions directory in there, but nothing else. So this is now a rather empty repository. I only pre-created that versions directory. All right. So that is about the Stratum Zero part. So I also put screenshots for all of these so you can easily read it back later in the slides. So in a real setup, you would now also set up a Stratum 1 and proxies. I won't do that in my demo setup because this is just, you know, a demo case and it's just for testing. But if you're actually going to use this in production, then it's essential for redundancy and load balancing, as we discussed. In my case, I will just directly connect the client to my Stratum Zero, which is also possible. In a real setup, as mentioned, you would typically set up two Stratum 1 instances and at least two proxies. And you can then configure your client with a proxy group that looks like this. So there's a sort of an OR character in between, and that causes the CFinvest client to randomly select one of the proxies, and only when that one is unavailable will it fall back to the other one. And because this procedure is random, there's about a 50-50 split between your clients approaching one of your proxies and the other. And again, you can reuse the same proxies that you're already using for software.easy.io. If you have a lot of local software as well, you might want to consider increasing the size of the disk on those proxies, right? But yeah, I'm not assuming that you're going to have thousands of local software installations, so you're probably good. Again, there's a specific tutorial also on how to set up the Stratum ones and the proxies. Now, you might be thinking that's a lot of hardware that I need. If you're short on machines, you can pull some tricks. You can set up one Stratum 1 instead of two, and then also list your Stratum 0 in the StreamInvest server URL. That works, but mind you, that means that you need to open up your Stratum 0 to all of your client machines. From a security perspective, that is not super nice because the Stratum 0 is the one where you can actually put new software in. So yeah, if there's some kind of vulnerability and somebody from your client machines manages to push some software, malicious software into your Stratum 0, that's something you don't want. So yeah, from a security perspective, it's not super nice, but you could do it if you're short on hardware. Another option is that you can use two Stratum 1 instances and no proxies, but then you still need the proxies for easy. So there's not really a big point here. If you would take this approach, you can still get load balancing. Like the tricky part is that if you disable the use Geo API, you know that your clients are going to approach the Stratum ones sort of in the order in which they're listed in the StreamInvest server URL. So then by configuring half your clients to approach instance 1 first and half of your clients to approach instance 2 first, you get both the load balancing and the redundancy. So that again is an option if you're short on machines. Again, if you also already have a private Stratum 1 for software.easy.io, you could definitely reuse the same machine to serve one of your site instances, right? But you still would need a second one for the redundancy. Then about the local clients, your local clients need a StreamInvest package installed. They also need to know about the public key on the Stratum 0, so you can actually take that from your Stratum 0 and put it into your clients. They need a minimal amount of repository configuration. So you typically put this under /etc StreamInvest config and then the name of the repository and then .conf. And you need to tell StreamInvest that this repository actually exists. So you add it to the StreamInvest repositories list in your default local. Again, for this demo, I connect directly to the Stratum 0. That is not recommended for anything but a test setup. So yeah, if you read the proper documentation on setting up a client, you would typically connect to a Stratum 1 and configure proxies in there as well. All right, let's go have a look at that machine. So I have a second machine that contains the client. Let me see. So the first thing is this default local. That's basically providing the StreamInvest repositories. Here I actually have a couple because I played around a little bit, but this is the one I really care about, right? Software.caspar.nl. That's the one I'm going to play with in this demo. And the quota limit is actually the amount of local cache that this one will use, this client. Then we have the public key. That's in StreamInvest keys, then the name of the sort of the domain, and then the repository name .pub. That's just a regular key as you would expect it. You obtain this one from the /etc/StreamInvest/keys directory under Stratum 0. So if I look at under Stratum 0, let me bring that back again. There's a etc StreamInvest keys there. And in there you have a couple of different keys. One of them is this public key that we're talking about now. Oh, and going back to the client. And the last thing that I wanted to show here is the minimal repository configuration. So that is here. I've listed the server URL, so this is now directly the IP address of the Stratum 0 that I'm connecting to. I've disabled Geo API. It doesn't really matter if you have a single item in your server URL list, but fine. You can configure the keys directory. So this is actually the default, but you can tell it to look somewhere else. And I tell it, I don't have any HTTP proxies configured, just connect directly to my Stratum 0 or my Stratum 1. Again, that's only for the test setup. All right. Going back to the slides. So now we have a start from zero setup and we have a client setup. The next thing we want to set up is the Easy Build Bot, but let's talk a little bit about what the Easy Build Bot does, what it is. Basically, the Easy Build Bot is designed to start jobs and run scripts when it's triggered by certain GitHub events. So it's quite a generic build bot. It can start jobs with any script, and you can do this by replacing Easy's bot/build.sh script with whatever you want to do as a site. That level of configuration is quite involved. So this is why actually in this approach we're using the bot build sh script from the upstream software layer script repository, because then you don't need to maintain your own. And then the Easy Build Bot will store tarballs wherever it's appropriate. So it will build something, it will create artifacts, and those tarballs are stored somewhere on a shared file system in a location that you can configure. And also the bot will actually report back. So it's triggered from a PR using a certain command, and it will report back in that same PR like, oh, I've submitted the job. I'm now waiting for the scheduler to schedule it. It's running. And finally, I have a successful job and a successful test step, and eventually also a successful upload to my object store. So this is how we would like it to look at the end of things. Now, the existing build bot has a few requirements. It needs to run somewhere where it has access to a Slurm cluster, right? So it needs to be able to execute sbatch commands in order to submit the build jobs. It needs to have permissions to start build jobs, of course. And this thing is a GitHub app. So basically you need to configure a GitHub app in the GitHub web interface and install it onto a GitHub repository. So that's how it communicates with, like how you communicate from the PR with the buildbot instance that's running on your machine. And it needs a shared file system to write in order to run its build jobs. We're actively working on GitLab compatibility as well. That is not there today, but I think this will be coming soon. All right, so now about setting up the build bot. We need a couple of items here. One of the things is a SME channel. SME channel basically relays GitHub events. You want to set up one SME channel per bot instance. So if you have multiple clusters that you want to build for and you have multiple build bots running there, give each of them their own SME channel. Otherwise, things are going to get confusing really quickly. And what we do is we'll create a SME channel, and then a SME client should be running that connects to that channel. I will not actually create the channel as part of the demo. I will just show you how it connects to it. Then the second step is that we need to register a GitHub app. So we do that via the GitHub web interface. There's a couple of things we need to configure here. And typically, if you do this as a site, you probably have a GitHub organization somewhere. You probably don't want to do this in a personal GitHub login. And then you go to the settings of that organization, to developer settings, and there's an item called GitHub apps. And there you can create a new GitHub app. The things to configure there are the webhook URL, which should be the SME channel that you just created. There's a secret that you can just create with a simple Python command that's actually listed in the documentation of the EasyBot software layer that I'll link at the bottom here. And this secret is used to verify the webhook sender. So basically, the Easy Build Bot that's running on your cluster will be able to see that this event was really sent from the GitHub repository that you configured it on. You need to set some permissions, like what is this GitHub app allowed to access, to read from, to write to, etc. And you need to subscribe it to events that this app should act on. So that's typically things like, okay, if a pull request changes, then I want this an event to be sent to this GitHub app. And at the end, you create the GitHub app, and you're asked to create a private key as well. That private key should be put on the machine that runs the build bot in the end, and then the bot instance will have to be configured in a way to find this this private key, and that's how it will identify itself to GitHub, right? All right, so registering the app. Let me actually show this live. Let's see if I can. Do I have that link? Oop, let me go back to slides. Yes. So this is what our own organization's list of GitHub apps looks like. I'll actually just edit the one that I created for this demo. so that you can see what it looks like. Let me get my token. So here are basically the things that I just named. You have to give it a name, a homepage URL. You can just give it the one for the SME channel as well. But the one where it really matters is the webhook URL. This is really the one that needs to match the SME channel. There's the private key that we've configured when we set up the GitHub app. And then there is the permissions page. And the first time you create this app, I think this is all one big list. But after the app is created, if you do edit, you get all of this in different tabs. So here we configure the repository permissions. What should this GitHub app be able to access and do? And actually, it needs to be able to read and write to issues and read and write to pull requests. So those two are needed for the GitHub app. And as mentioned, it also needs to subscribe to events so that it knows what to act on, and it needs to be subscribed to issue commands and pull requests. And then let's see, was there one more? I don't think we need to cover this. Yeah, then the second step is actually that we install the app, but let me show the slide for that first. This one. So there's defining the GitHub app, and then there's installing it onto a repository. Well, we can actually go here. So here you see that this GitHub app was installed onto a repository in our own project. And if I click the configure icon, you can tell it to be installed on all the repositories for this organization or just on selected one. I've only configured it to listen to this particular repository. So when I have a PR in this particular repository and I put some command there, that is an event that gets sent to my GitHub app, to my easy build bot, basically. Right. And then the final step is to actually install this thing on a machine. So this could be any machine that you have on your system that is able to submit batch jobs. So it could be a login node, it could be a service node, whatever works for you. Note that the bot instance itself is very lightweight because all the building happens within jobs. So the bot instance itself is basically only listening to these events, submitting a job, querying the job status every now and again. And when the job is done, it will send back a report to GitHub, right? So it will, through the GitHub API, it will actually push some content to the PR from which it was triggered. So that's all pretty lightweight. In order to get the code that runs the bot, you clone the EasyBot software layer. You set up a virtual environment in which you install the requirements for the EasyBot software layer. You have to make sure that the AWS and JQ commands are available. And in your environment, you have to put this webhook secret that we configured earlier in the web interface as well. That's how the app that's running on your local system knows that the webhook or the event was actually coming from GitHub. And then there's a step, and it's one step in this list, but it's actually the biggest step in all of this, which is configure the bot's app.cfg. So this is a one configuration file where you can tell the bot, like, where is my shared file system, where I want to use, where I want to store the jobs that I run, etc. So that's most of the work. And then optionally, you can create a configuration file for Reframe, which is the framework that we use to run the Easy Test Suite. If you do that, it can actually also run the Easy Test Suite as part of the installation. There's one caveat, it's not working yet today for site installs. So that is something we'll still work on, but yeah, eventually we'll make that work as well. So what I typically do is I create a small environment script because I don't want to remember, what I have to load and what secrets I have to set. Of course, the secret I put here on the screen is a fake, but I typically have such an environment script that I just source right before starting my bot commands, and then I can forget about what exactly I need to set. So I'll source my virtual environment that provides the requirements for the bot, and I'll put the secret app token in there as well. As I said, configuring the app.cfg is actually the most work. Things that go in there are things like the app ID. So if you look in the GitHub web interface, there's an ID associated with your GitHub app. And then when you install that GitHub app onto a repository, there's also an ID associated with that. So you also have to provide the installation ID in the app.cfg. You also configure things like the partitions that your machine has and how to submit to those so that the bot knows, okay, if I want to build on this particular partition, these are the flags that I need to pass to SBatch in order to make that happen. It needs to know the location of your private key that was created when you created the GitHub app. You need to point it to a shared FS where it can store job directories, log files, etc. And you need to tell it which GitHub users actually have the right to build stuff or to deploy stuff, etc. If you want to deploy to an object store, you also need to provide it with bucket names and S3 endpoint URL. If you don't set an S3 endpoint URL, it will assume you have a bucket in AWS by default. And then finally, you need to point it to a location where you store CMFS repository configurations. What this looks like is for every repository that you want to be used in a build job of the bot, it basically uses a container. So inside this container, it needs to have a configuration for a CVinvest client as well. And the way to do that is to provide all of the files that you would normally have on a client machine in order to access your site repository. And you bundle them together in a tarball because that's basically the format that the bot expects them in. So you'll recognize here there's a default.local, there's the public key, and there's the minimal configuration file that I basically showed on the client machine as well. So the contents of those files are basically the same. And then there's a small file called repos.cfg, which basically tells the bot, it gives a name to your repository. So this thing between brackets, that is the name under which the bot knows this repository. And then you need to make sure that you use the same repo versions as the EESSI versions that you're building on top of. And then you point it to whatever tarball you have that stores the configuration for this repository. And the config map actually tells the bot, how do I map these files in the tarball onto a location within the container so that CVFS knows where to find these files, right? So these are basically where it's mapped to. Those are the standard locations where CVFS looks for these configuration files. So that's exactly the same as we had on our client machine. And then the final piece of the puzzle is which container should be used in order to build for this repository. And you can easily use the one that we use upstream as well. Regarding an object store, I won't go into detail here, but if you want to make a bucket through the AWS commands, it's simply AWS S3 make bucket, and then you pass it an S3. I don't know if this is even called a URL, but with the bucket name in it. Some things to think about, consider setting up a bucket policy that restricts access to this bucket to whitelisted IP ranges. You know where your build bot is going to be running, right? So you know from which node you might push tarballs, and you know from which node your Stratum 0 will actually try to pull these tarballs. So it's generally quite safe to set some whitelisting on this so that you know it can't be accessed from anywhere outside. Because eventually, if somebody manages to put a tarball here that was not created by you, they might be able to get something into your software stack, which you don't want. You can also consider setting automatic cleanup policies on the bucket. That means that as long as those tarballs are, if you just keep adding tarballs, at some point you're going to have to do that cleanup manually, and probably they're outdated quite fast because typically you just ingest them into your Stratum 0, and then you don't need them anymore in your bucket. So you could set up something automatic for this as well, or you have to do it manually every now and again. And then as a final piece of the puzzle, you create an S3 token and store the corresponding AWS access key ID and the AWS secret access key in your environment or in the $home.aws/credentials file. So these are the two methods that the AWS command by default uses in order to check for credentials. So again, you can put this in your environment file, the same environment file that I used before to load my virtual environment and set the GitHub secret key. You could also set your AWS keys there if you want to. Maybe as a final comment there, it's nice to rotate those keys every now and again just for safety. Then another piece of the puzzle, we need a repository that lists what we want to build. So this is basically a repository that is very similar to what EESSI software layer looks like. It needs to have the same build.sh if we want to use the same build scripts that we use upstream. And it needs to mimic the directory structure for the EESSI stack files, because that's where the build scripts will look for what needs to be built. So it needs to have a directory EESSI stacks and then the name of your CVMVS repository. So in my case, that's software.caspar.nl. Then the version, the EESSI version that you're building on top of, and then an EESSI stack file. And also for the EESSI stack file itself, we have a standardized naming scheme. It needs to be EESSI dash, and then the version that you're building on top of dash EB, the EESSI build version that you want to use to build this thing. And then you could do a dash anything. So if you want to put some informative suffix there for yourself, you can do whatever you want. In EESSI, we typically put the tool chain that we're building for as this dash anything. And I actually have an example of this in a pull request. Let me see if that is the most recent one. No, I actually wanted to show the other one, I think. Yeah, I opened a new one. So the only file I changed here is that I added an EESSI stack file. And if I look at the main repository, right now, the only thing this contains is this bot.build.sh from upstream. So I basically copied this from upstream. It's only a few lines of code. So yeah, you might want to watch out for changes that we make upstream. See if you need to add or change anything here. But that's a minor effort since it's only a single and very small file. All right. Then if we have a tarball that we've pushed to a bucket, then of course at some point we want to ingest that into the stratum 0, so make it available in our CVMVS repository. So we need a little script that does that, or we need to do it manually, right? I mean, both are possible. I've actually created a script as an example that basically does these steps. So it checks for new tarballs in the bucket. If it finds one, it downloads the new tarball to the stratum 0. You can check the signature, so the bot can sign the tarballs, and then you can check that on the stratum 0 using a public key to see, to verify that this thing hasn't changed in between the batch node that built it and the stratum 0 that ingests it. Right now, the example script actually doesn't do anything. Like it calls a generic executable that on my stratum 0 doesn't do anything. But you can actually update this to check the signature. Then we actually ingest it, all the tarballs that it finds, and it updates the CVMVS catalog files, come back to what those are, and then it updates the LMOD caches for the new installations that you've done. Here it says can be done soon. Actually, it can be done today because we merged this today. So there's a script in our EESSI file system layer repository, scripts called ingest_tarball.sh. That's also leveraged by my example here. And that actually does sort of these three things for you. So ingest it into a CVMVS repository, update the catalog files, and update the LMOD caches. Then finally, you probably want to move or remove the tarballs from the bucket, so they only get ingested once, right? Otherwise, every time the script would run, it will try to re-ingest the same tarballs. That's typically not what you want. So just to show what that looks like, so this is in our organization's GitHub repository. So this is not something that's officially upstream in EESSI, but I just hacked something together with the help of an AI friend that basically does these steps, right? So some minor configuration that you can change for yourself if you need to. Then it gets the list of tarballs that got added. If there are no new tarballs, that's it. But if it did find new tarballs, it will loop over them. It will download them. It will download the metadata file, which enables you to check the signature. It will run this check signature code, which on my machine does nothing, but you could actually implement a proper signature check there. And then it will call this ingest script in order to ingest it into the CVMVS repository. And this ingest script is actually one that is coming from the file system layer. So that does the three things that I mentioned before. It does a CVMVS ingestion of the tarball, an update of the catalogs, and an update of your LMOD caches. And then after the ingestions, I remove the local files that I downloaded. I archive the objects. So in my case, I actually move the objects in the S3 bucket to an archive directory. And because my first step excludes looking into the archive directory, I will never see them again unless I need them, right? I could still manually retrieve them if needed. And then that's it. Then it's done. All right. So yeah, updating the element caches, there's a little bit of a detail here. If you want to do this, there's a script that Elmot provides. And if you have software.easy.io available on your Stratum Zero, you can actually use the script from the Elmot installation that comes with software.easy.io. I think that's the most convenient way. You could also install Elmot onto your Stratum Zero and then use an environment variable called Elmot libexec_dir, which points to the libexec directory of your Elmot installation. And then it will use that one. One thing to be aware of is that these caches, they are typically forward compatible. So if you have an older cache, that typically works with a newer Elmot, but not always the other way around. So it doesn't break every version, but we've seen it break in EESSI. So that's why for EESSI, we now actually use the oldest Elmot that we provide in software.easy.io to generate the caches, so that it will work with all the other Elmot versions that we have in there as well. So in order to make software.easy.io available on your Stratum Zero, it's a little bit tricky because you want to do that without enabling the auto mounter. And the reason is that if you want to run the cfnvest server command to ingest anything, it will complain if the auto mounter is enabled. It says, I can't do it. So on a normal client, you would just, put the configuration files there and run cfnvest config setup, and then the repository is available, but that's not the way to go here. Instead, we want to mount the repository manually. And we do this in two steps. We first mount the cfnvest config repository because this will provide the configuration for our software.easy.io repository. In order to do that, we first create the directories that we need. So that's basically the point that we're going to mount to. And then in the etc fstep file, we're going to add a line to mount the cfnvest config repository and then the software.easy.io repository. My system told me when I ran the mount command, hey, you need to reload this daemon first. Okay, fine, I do it. And then I just mount whatever is in the fstep file again. And then I have the software.easy.io repository available on my Stratum Zero without having the auto mounter enabled. So then the cfnvest server command is happy to ingest anything you want. Maybe one note, Bob showed in the beginning an image of how the build mod works on upstream EESSI, and there was one additional step there, which is that from the cfnvest Stratum Zero, there was another PR created, which is a staging PR, which gives us a final opportunity to check things. That is likely unnecessarily complex for sites, so we don't really recommend to do this for a site installation. That's also why my script doesn't do it, right? It just checks for tarbles and ingests them. That's it. A note about cfnvest catalogs. So cfnvest repository uses a nested catalog for storing metadata. So that's basically telling your cfnvest clients which files exist under a certain hierarchical directory structure. And one important item is that catalogs should not become too large. So as a rule of thumb, they should be between 1,000 and 200,000 items, which means files or directories. And what we do for the EESSI repository is that we make a nested catalog for every software installation. So in the root of the EESSI build installation directory, that's where we want to create one of these catalog items. The way we do that is by putting a cfnvest dirttab file in the root of our cfnvest repository. This is also documented like in cfnvest that this is a way that you can do this. And if we look at what our upstream file looks like, let me see if I can quickly open that one. It basically gives you a pattern of directories, and in every directory that matches such a pattern, it will create a catalog item. In your site installations, you won't have any of these, right? You don't have a compatibility layer, you're just building on top. So you can actually remove those On the other hand, CFMVS is intelligent enough that if there's patterns that don't match, it will just skip the catalog creation. That's it. All right. Yes. So you can make your own CFMVS dirt tab file and just put it in the root of your own site CFMVS repository. You can simply copy the one from EESSI and that will probably work. If your prefix is slightly different, then you're going to have to adapt those directory structures. There's another option. CFMVS also has functionality for automatically managing nested catalogs. So then it will just consider the number of files and break it up when it gets too big. I guess the only downside I can think of is that CFMVS doesn't know which files are commonly accessed together. So in our case, we know that files from the same installations are typically accessed together. And it's actually nice if they are stored in the same catalog, because then only one metadata item needs to be retrieved in order to have access to all the files from that installation. On the other hand, if you don't want to bother with the CFMVS dirt tab file, probably you're going to get very far with the automatically managing nested catalogs. All right, that's a lot of setup, but now we have all the prep work done, we can actually start building something. So let me switch over to the terminal again. There we go. Okay, to another tab. So here I have a directory where I have a small script to start the SME client. That's basically because I'm too lazy to remember where to pull the Docker container from and which URL I want to connect the SME client to. And this just gives me a simple wrapper to start the SME client. So that's the third thing I'll do. It tells me, okay, you already have this container file. I don't need to re-download it. And it started the client and connected to this channel. Then in a second terminal, I will actually load my environment. So this is the little environment script that I have in order to provide the bot configuration. So now I have my virtual environment set up. I have the secrets configured in my environment. And then in the EasyBot software layer repository, so this is a local checkout of the EasyBot software layer repository. I start the event handler. There's two processes basically that are part of the bot. There's the event handler and the job manager. I need to start both of them. Again, here I load the environment. I'll go to the local clone of the EasyBot software layer repository. And here I will start the job manager. The event handler basically listens to events and, for example, prepares the build directory and submits the first job. And then the job handler takes over and keeps querying the job status. And when that is finished, it will report back in the upstream repository that it's done. So now all the bot processes are running. Let me see if I covered everything. Yes. And then we go to this upstream PR that I had, which I have open here. I actually already triggered the build bot before this webinar because it takes 10 minutes to build. So this is the command that I normally use. I tell it, okay, the action that I want to do is to build. I tell it which repository to build for. Now this name basically matches what was in the repos.cfg file earlier. This is just the instance name of my bot that's configured in the app.cfg. A bot that has a different instance name will simply ignore anything that's not targeted at that instance name. And then here I basically tell it I want to build for this particular argument, for this particular architecture. You can also optionally pass it an on argument. If you don't do that, it will assume that you're building for the same architecture that you want to build on. We typically only provide an on argument if we want to cross-compile for accelerators, for example. So then we build on a CPU-only node, but we want to build for a GPU target. I can trigger a new build. Well, the first thing I would actually do if you have a bot instance running is just to ask it to show the configuration. That way you know, is it actually listening to my repository? Did I configure everything correctly? This takes a little bit of time now on the other side. It should receive an event and there it comes back. and it posts a message. Okay, this is the bot instance. This is the name of that instance, right? So that's what I use in my bot build command. I know about these different node types. Now, these node types are just generic strings, but what they mean is basically configured by what they submit to, right? So, okay, this is configured to build for a Zen 2 architecture. It's configured to build for these and these and these repositories. Of course, this is the one that I'm interested in, right? That's my demo repository. And I realized this might be a little bit small. Let me make it a little bit bigger. And it's actually configured for all of the 4 repositories that we have on our HPC system. Sorry, for all of the 4 architectures that we have on our HPC system. All right, so just to trigger a new build, just to show you what that looks like, we'll not wait for the end result, but again, I just post a comment. And if you look actually at the bot process, you will see some activity here in the SME client. You see, oh, there's something coming in here. And I can check the log files, and then you'll see a lot more, of course. Then you see that this request comes in, the event handler is first handling it, and then hopefully it's submitting a build job to actually do the build. And this is also reported back in the upstream PR. So the bot reported back, I'm going to build on this architecture for this architecture. This is the job directory that I've created. So it will use a single prefix for a single job. And that also contains your Slurm log file. So if you want to check something that went wrong, that's the place to look. And then it tells me, okay, I submitted it. I've waited for it to be launched. Now it's running, and now it will be running for another 10 minutes before it completes. We won't wait for that. Instead, we'll go to the next step. If I have a successful build, as I mentioned, the build is successful. The test step is not yet successful because we haven't properly implemented that for site installations yet. Fine, we can ignore it for now. It just means that you don't get the EESSI test suite run as an extra validation, basically. You can, of course, still run the EESSI test suite manually, but then you have to do it after already ingesting it. And then if it's broken, okay, you have to remove it again. That's a bit annoying. So what do I want to do? If I want to deploy it, I just add the bot deploy label. So the bot also monitors for this specific label. As soon as it sees it appear, again, we'll see an action here in the SME channel. You will see some activity. We might have already missed it. No, there it is. And it will actually report back, oh, I've now uploaded the tarball that was created in this build job to the S3 storage, and this was successful. So now if I query my S3 storage, let me see if I can do that from the server where I have my AWS credentials configured. I can see the top 2 are basically the new tarball and the metadata file that it just uploaded for this build. The other ones are in the archive directory, so those are like tarballs that I've created earlier and I've already ingested. All right, so now there's something that can be picked up by the stratum 0, and that can actually be ingested. So that is going to be the next step. And you could put this script on a cron job, right? This is basically the script that I showed from the repository. So this is this, well, let me show it again. The ingest tarballs. That's the one that checks the bucket for new tarballs and then does the ingestion. Let's run it. And maybe before we do, let's make sure there's nothing on the client machine. If I now look in this software.nl repository, the only thing that's there is this versions directory, and there's nothing in it. Now, if I ingest a tarball on the stratum 0, this will take a bit of time. It will do a fake signature check, but you can do a real one. You see a couple of items that might be interesting to have a look at. Here you're seeing it's creating the nested catalog items based on the CVMS dirt tab file. So you recognize, hey, I get warnings because these patterns actually don't exist in my repository, and CVMS just warns me I'm not going to create a catalog file in those prefixes. That's totally fine. Then there's this little piece of output. It actually created an lmod cache for me in this directory and then /.lmod. and it update, or if there was already a cache there, it will have updated it. Now it actually created a new one because there was nothing there yet. And then finally, my script just reports, okay, the ingest succeeded, so I'll archive the tarball. So it moves it within the bucket to this archive directory so that the next time I run the script, it will just tell me there's nothing to ingest. Oof, no new tarballs found in the bucket. And now on the client, I will probably not see it immediately because it takes some time, but you can do, you can force a reload. Let me see if this is indeed enough. I think so. This will reload the repository because there is a certain time at which the cache is still valid, and in the old cache, these files weren't there yet. Now, if I do an ls again, I will actually see the new directory. And within that directory, I actually have this new software installation, which was for BioPython. So yeah, this is basically the easy build installation prefix of my new installation. And that means that now if I have, let me think, I don't have easy initialized yet, I believe. Let me check. Do I have a module command? Maybe I do. This actually takes a bit of time because it has nothing in the local cache yet, right? It's completely empty. Okay, there are no modules loaded. Let's see if we ask it which BioPython modules are available. That's not good. Okay. I'm not sure which module path it searches here. I'm not sure what I initialized. That might be the issue. Okay. So it only searches the easy one. So what do I need to do? I think I actually have that in the slides as well. Let me go back to the slides for a second. So we've done this, right? We triggered the build, we've added the deploy label, we've actually ingested it into the Stratum 0. And now to actually use it, let me copy those commands so that I don't get the prefix wrong. Wait a second. Yeah, there we are. So I will set the easy side software prefix. I will source the initialization script. And now hopefully I should have the new module path set. Let's see if that's true. Yes. Now I also have a module path that includes my own site repository, right? So now if I do a module avail BioPython, I should actually see it. Yeah, there it is. Now I actually see two versions because there was already one upstream, but it was an older version with an older toolchain. And I now installed a new version with a new toolchain. I can load that one. And just to show you where it now gets its files from, or maybe let's run which Python first, because then you see that the Python it's using is actually coming from upstream easy. But now if I run this command, I just import the Python package that comes from BioPython. Is it doing something? Again, it's a completely empty cache, right? And apparently this Stratum 0 is not the fastest machine in the world. So this should only be slow the first time around. If you have proper proxying on your system setup, then this should be a lot faster. But let's wait. Yeah, there it is. And now it tells me, okay, the path that I got this thing from is indeed the site CVS repository. So yeah, basically now we have built successfully on top of easy with all of the easy tools that we have at our disposal. Let's go back to the presentation. So just to revisit the goal that we set originally, build using dependencies from easy. Yes, we did that. We did this in a CVS repository of our own. We used the easy build bot. And actually, here I said, well, we're almost there. We are there now today. So we are actually using the build script upstream that easy uses because we merged this PR right before the webinar. So this is now functionality that you can use. And then I give the floor back to Bob.
Yes, let me share my screen again. That one. I'll try to speed up a bit, a few more slides, and then we're done, but only have half an hour left. We also want to reserve some time for questions and discussions, of course. Yes, there we go. So a few special cases and special scenarios that you have to take into account when you're going to use this, either with the way the approach that Caspar has shown or the approach that we've shown before. One tricky sort of use case is licensed software, where you can have several kinds of licensed software, either licensed software that you are allowed to ship in your CVMFS repository in some way, or either software that maybe is only accessible to a group of users. So on our local stack, we actually have both use cases. For instance, for MATLAB, we ship that in our internal CVMFS repository, but that's sort of firewalled and can only be used on the university network, which is fine. But we also have licensed software that can only be accessed by a group of users, and that's a bit more tricky to do with CVMFS, because by default CVMFS makes the entire repository available with the files being owned by a user CVMFS and a group CVMFS, which means you cannot really restrict that to certain Unix groups. Now, there is a client flag which allows you to do that. That's this CVMFS claim ownership. Then basically the ownerships are taken from the Stratum 0, so in the way that you ingested them. But it's very easy for a user to work around that. If they know something about containers or CVMFS, you can easily mount the repository yourself without that flag, and then you can basically just access anything. So I would not really recommend that if you want to be safe. But unfortunately, that means that there's not a really good way to ship such software on CVMFS. So for those ones, I would suggest that you still put those on a shared file system somewhere on your system, and then use Linux groups to make them available to particular groups. Some cases might be easier if you can still ship the software without the license file. Then, of course, that's possible with CVMFS. And then you just set some environment variable on the machines themselves, on the client machines, where you actually point to the license file, which can still be on a local disk or on a shared file system with the right permissions. One other thing which I had just added to the slide, where I realized that that's also often an issue with licensed software, because licensed software is often shipped as binaries. You don't have the sources. They're pre-built, and that means they are not aware of the EESSI compatibility layer, which is on CVMFS in a non-standard location. And that means that they will pick up the wrong linker, basically the linker from your host system and not the one that EESSI ships. And that makes them in some way incompatible with all the EESSI modules. Often that can be fixed, but then you have to patch the binaries using patch elf and point the binaries to the correct linker inside the EESSI compatibility layer. But summarizing, yeah, licensed software is a bit tricky. Since EESSI itself only ships open source software, we don't have a lot of experience with this yet. So you as a site will probably run into this once you start building licensed software on top. You can maybe reach out then on Slack if that happens. Some people, especially in Austria, for instance, they have some more experience with this already. They've been building software on top of EESSI, also licensed software, so they might be able to help out. But it's good to be aware of this. Another one is software rebuilds. If you have attended last year's webinar, we had a sort of similar webinar about this topic. Rebuilds were still a bit tricky because we make them read only in the CVMFS repository, and then it's hard to override them with a new version if you ever need to rebuild that package. So if there's a patch or some bug and you need to rebuild it, that used to be a bit tricky. We now use a container with a different kind of overlay file system, and that fortunately works much better. So that should be easily doable now by basically following the same workflow that Caspar has shown you before. But instead of putting the EESSI stack in the regular directory, you add a subdirectory rebuilds. And whenever the build scripts from EESSI detect that EESSI stack file is coming from a rebuild subdirectory, it will do sort of the usual thing, except that it will also add this -- rebuild flag to easy build, which will instruct easy builds to forget about the old installation and make a new one anyway. And then you can just trigger the bot in the same way. If you need to remove software, sometimes it may be good before a rebuild to actually remove installations if they have files that should not be there. That cannot be done with the bot yet. Maybe that's a feature that we could implement in the future. Right now, that's a manual operation, so will have to go to the stratum 0, open a transaction, remove the actual software directory, also remove the modules that belong to that installation. And then to really get rid of it, otherwise users may still get the feeling that the module is still there, because module fill will still show it even though the installation directory was removed. You will have to update the lmod cache, which you can do manually with the command listed here. And then you publish that CVMFS transaction, and then a few minutes later, it should have been removed from the view on the client side. And then the very last topic, assuming that you've built your own site stack in either the way that I described in the first approach or the way that Caspar described, you probably want to make this available to your users in some automated way. So for instance, every time they log in, they automatically get to see all those modules. That's easily doable, but there are like hundreds of ways that you can do it. So probably you know best how to do it based on how you set up your own cluster already for your current software stack. But there are some important variables here that you probably want to be aware of, which you can use to configure everything to your liking. An important one is, of course, that easy site software prefix. So if you used your own CVMFS repository or some shared file system, you want to point that variable again to that directory so that the easy module is aware of it and automatically adds that to your module path for the users. So just put that somewhere in the file in, for instance, etc profile.d, and then users will automatically get that in their shells. Two other ones that you can use for the easy module is easy module sticky. For our site, we typically make these meta modules which load an entire software stack sticky, so that if you do module purge, it will not by default unload that meta module. If you want that, you just can set this environment variable to 1 and it will automatically make it sticky. Similarly, we have a easy module family name. That's a sort of lmod feature where you can assign a family name to a module. We use that locally on our cluster to sort of define the same family name to the easy modules and to the meta module of our own local stack. And that enforces lmod to basically disallow users to load them at the same time. So you can never load both stacks at the same time, the local stack and the easy stack. So that's useful if you still have an old software stack that was built without easy. That's probably not compatible with modules from the easy stack, and then you probably want to use this. Once you start building on top of easy, you of course don't need that anymore, because you basically merge them together and they are compatible with each other. So this is only for your old stack to really enforce that they are never loaded at the same time. Then there's a whole bunch of lmod configuration variables that you can use, for instance, which pager you want to use and all that kind of stuff. And that's all documented in the lmod documentation. And then just to give you two examples how you could do this, with lmod, you can basically choose if you want to use the easy lmod, which is shipped in the compatibility layer, or if you want to use your own lmod, assuming you already installed lmod on your cluster. So in the first case, if you want to use easy lmod, you can do something like this: make a bunch of files in etc profile.d that define that easy site software prefix, and for instance, point it to Caspar's CVMFS repository. You source the init lmod script. So here we use bash. We also have versions for other shell types. So you just source the correct script here, which will basically initialize the lmod from easy and point it to the easy module files for the different easy versions that we have. And then when the user logs in, they basically get all the easy modules automatically loaded in their environment, also the ones that you as a site offer on top of easy. Same can be done if you want to use your own lmod, assuming you already have this. So you basically have these three files. It's also sort of based on the LMOD documentation, but again, there are lots of different ways how you could do this. So you can make this 01 local LMOD, which defines which pager you want to use for LMOD, which module paths you need for maybe custom modules on your cluster. And then you can define a sort of standard environment. I will show an example of that in a minute or so. But that basically defines if you want to auto-load modules upon login, for instance, which EESSI version or some other module that you make available on your cluster. LMOD also has a sort of standard environment meta module for this, which you can also use to configure anything that you would like to have set when users log in. So just a quick demo, though I don't have much time, but let me just go through the slides here. That will probably give the idea. So this is the file where we basically just define how we want to configure LMOD itself, module path for EESSI. And here I'm using the LMOD of our own cluster, by the way, forgot to mention that. I pointed to my /software mount, which I created before. And then I configured case independent sorting because we like that option. We don't want to use a pager, etc. So that's not very important for now, just details how you want to configure LMOD. And then the other file basically says if LMOD was not initialized yet with the default modules, then initialize it like this, then add this EESSI 2025-06 as the sort of standard module that needs to be loaded for every user that logs in. If you use those files in your etc profile.d and then you log in as a regular user, you don't have to do anything. So you just do module avail, and then I will get to see the modules that were built with a different user account in this /software shared directory, which I think is something that would be useful in the end, that you can make it available in this way to your users. You still have options to configure it to your liking, so you can choose if you want to load it EESSI version by default and which one, or maybe you don't want that, you want users explicitly to pick one, then you can of course take that out. So there are a lot of ways how you can configure this. All right, time to wrap up. Some future work that we still want to do. So provide documentation basically for everything that we've shown today, and that's still lacking in the documentation. There's something about EESSI extend, but not really about how to build a site stack on top of EESSI. So we should basically convert this entire webinar into proper documentation. Some questions that also were recently raised on Slack, but I think we already had this in the last year's presentation as well. So we rely on EESSI build hooks quite a lot, also with EESSI extend, that loads EESSI build hooks from our software layer scripts GitHub repository. And there are quite a lot of hooks in there already, but you as a site maybe want to add hooks on top. And currently that's not really supported, other than take the file, edit your own hooks, override the location, and then use that. But then you might miss out on stuff that we add later on. So we're looking at options to basically have a hook-in mechanism for the hooks files, so that you can easily add your own site-specific hooks on top. I think EESSI build also has a feature now with entry points, which might make this easier, but we have to start using that and document it in the documentation. And finally, for sites, also offer more module naming schemes. So right now we only have a flat module naming scheme in the EESSI CVMFS repository. Lots of sites are using hierarchical schemes. You can rebuild the entire stack with only rebuilding the module files without rebuilding the actual installations themselves. But that's quite a bit of work. It's also not very straightforward, but as EESSI, we can easily provide these for you. Whenever we build modules, we just build the several variations that we want to support. That's also something we're looking into maybe for the next EESSI version. Then we still have a bunch of discussion items, but I guess it makes sense that we first go to the questions, and then if there's time left, we can maybe go through one or more of these.
Yeah, thanks a lot to both of you. That was a lot of content, and so now whenever I want to install the bot, I just see the presentation by Caspar. So there are a couple of questions. Maybe you can say something about this, or maybe point to documentation. What are the hardware recommendations for Stratum 0, Stratum 1, and Squid proxies?
I'm not sure if we have that in our documentation. We definitely have that in an older CVMFS tutorial that we gave a few years ago. But yeah, it depends a lot on how many clients you have and how much you're going to use the whole CVMFS infrastructure. In general, the Stratum servers don't need a lot of cores, don't need a lot of memory. For the ones that we are using for EESSI and also internally for our site, just 2 or 4 cores and like 8 or 16 gigs of memory is usually enough. The main requirement is lots of storage. The amount of course matters on how many installations you're going to provide in your repository. A good network connection between the client and the proxies and or the Stratum 1. That's of course important because they are pulling in files all the time from that Stratum 1. And SSDs can help if you're accessing a lot of files. Then of course SSDs are much faster than traditional spinning disks. But yeah, main requirement is network and disk space and fast disks.
Yeah, and to give some idea, like Bob, you know how much the EESSI repository is right now, right? So if you would want to have a private Stratum 1, which was one of the examples that we gave, like where you can install your site Stratum 1 on the same machine where you have a private Stratum 1 for EESSI. I think for EESSI right now we're getting close to 1 terabyte, or
in terms of disk space, yeah, it's almost 1 terabyte for basically 3 repositories that we have. So the software.eeessi.io, dev.eeessi.io, and risk5.eeessi.io. For all the different versions, all the different CPU targets, in total, that's almost 1 terabyte now. But that took like, the oldest version is 2023. So that took 3 years to get to that value. Yeah, CVMFS does a very good job in deduplication. So if you have the same installation for different architectures and only some binaries are different, that will save you quite a lot of disk space. But yeah, especially if you have a VM, for instance, you can easily probably increase the disk size later on. So start with a few hundred gigs or something and then increase when necessary. For proxies, more is better, of course. The more cache space they have, the more they can cache and the faster the files can be accessed on the client. I would say at least like 50 to 100 gigs. And yeah, if you have more, if this space is not really an issue, you can add a bit more there.
So maybe just to give an example for Snellius, we actually host a private Stratum 1 for EESSI as well. And there we're running it on an NVMe drive, which is something like 3 point something terabytes. So we can forget about it for the next 5 years, right? Like it's there. As long as that thing keeps running, I don't need to do anything with the storage anymore.
That's
and
for
that
your
has proven to be
proxy
quite.
or Stratum?
Sorry?
That's for a Stratum, Stratum 1 or Stratum
Yeah,
0?
that's a Stratum 1. Yeah.
Stratum 1, okay, yeah.
What's also worth mentioning here is that there's a feature coming up in CVMFS to do partial mirrors, right? So if you're today going for a couple of terabytes, and then as soon as you get short on disk space, you could start looking into the partial mirroring, and you'll be good for many years to come.
Yeah, that's definitely useful. So then you can easily tell your Stratum 1 to only sort of sync a part of the repository. For instance, if you're not interested in all the ARM builds that EESSI provides, you can just disable that and that will save you quite a lot of disk space.
And I mean, for your local infrastructure, it really depends on how many local software installations you're planning to do, right? I mean, you know that better than anyone. I assume for us, it's going to be the exception, right? Like most of it will push into upstream EESSI. And then on an exceptional case, we'll deploy something in our own CVMFS repository. So I don't think we'll need a ton for that. But yeah, depends per site maybe.
Okay, quick question. The container we use, Obtainer, right? Basically, we use that. Maybe in some scripts, we have still Singularity as sort of as the name, but basically it relies on Obtainer now.
Yes, though the image itself is being built with Docker, so it's stored as a Docker image on the GitHub container registry. But for actually running it with our script, that needs either Obtainer or Singularity. It uses some fuse mount flag that Obtainer has to basically mount CVMFS inside the container. So you don't even need CVMFS on the build host. You can basically build it on the machine without CVMFS. think it might be possible to do a similar thing with Docker, but I'm not sure if you need extra privileges for that. So for AppTamer, you can run that in a completely standard user account and still get CVMFS mounted. And that just pulls in that Docker image and then runs it.
Yeah, okay. Okay, another question. You answered that already. May I just read the question for everyone? Is easy site software prefix or that environment variable required to be set on user shells? If so, where do you typically set it? Right, you already answered it.
So you that's why I put it here in the etc profile.d file. So we just set it to the installation prefix. I think Caspar did something similar somewhere on one of the slides. Yeah, right here. So if you want to use it as a user, you still have to set that prefix to the right location and then load the EESSI module, and then it will automatically pick up all the installations that it can find there.
Okay, thanks. And then there was a question to get in contact with the Austrians.
Okay.
Okay, so far I see no more questions, but please don't be shy. If I don't see any further question within the next 3-5 seconds, then maybe we can stop the recording, or maybe should we go through these questions you have here, discussion items?
Yeah, it could be useful. I don't know if people want to answer them while being recorded, or we stop the recording first. Both are fine with me.
Yeah,
I mean, these are questions that we don't have a clear answer to, maybe. Anyway, and some input would be nice.
Yeah, I suggest maybe we stop the recording, Kenneth. Yeah.
Okay.
Oh, let me try that. Okay. Okay.